Right, so we have started a new unit, or we're going to start a new unit today. Quiz 9.1 is what you just finished. Assignment 9.1 is what's going to be assigned today. It's real easy. First period easily finished with lots of time to spare. So before we get started on that, I'm going to pass out your on rates. Rates of reaction. How fast do things move? How fast do things go? First thing we're going to talk about is how to identify the factors that affect reaction rates and how do we relate that to concentration versus time graphs. We're working on a lot of the Utah core today, and we're going to do some demos with dry ice and different kinds of water later. We are going to do an assignment, 9.1. Like I said, all of first period finished with lots of time to spare. So we've got plenty of time to work. Okay, so here we are in our notes. So first of all, we need to describe what is rate. Rate is the change in concentration of any reactant or product over the change in time. Now, remember, change can be denoted by a triangle. So that yellow box right there denotes the rate of the reactants going away because it's a negative. So rate when it's a negative means that things are disappearing. If it's a positive, it means it's appearing. So we use a positive for the products. So you can sort of see how the rate changes if it has a coefficient in front of it on the bottom. The graph that we've got there, we're actually going to be doing some of those graphs later. We start with reactants, we don't have any products, and over time we lose the reactants and we get more products. Sometimes the reactants go all the way to zero, sometimes they don't. We're going to be starting with some reactions now that can go both ways. Can go from the product to the reactant or the reactant to the product, depending on the stresses that I apply to the system. Okay, so the things that we're going to be talking about, the factors that affect rates of reaction, there's a bunch of them, and you only have some of them listed. But the first one, nature of reactants, that in itself, if they won't ever react, then if I try and put them together, the rate of reaction is zero. So there's no rate of reaction. So I've got to have reactants that will react. Concentration is something we'll be using to vary. Surface area is something we'll be using to vary. Pressure only works if I have one or more of the reactants or the products being a gas. If nothing's a gas, then pressure doesn't work to affect it. Temperature we're going to be working with, and then if I have a catalyst, and we're not going to be working with that, but if I have a catalyst, I can change the rate of the reaction. Some catalysts just lower the activation energy, but some catalysts will speed up the reaction. Okay, so we're going to watch a little video here. I'm going to put this on pause. That gave you a quick, easy way to remember stuff. So how to get dates to dance as a chemist. So we're going to go forward and we talk about each one of those. Temperature. What do you tell you about temperature? You increase it to make the particles go faster. If the particles go faster, then the reaction rate is faster, right? If the reaction is going too fast, though, and I want to slow it down, what do I do? Decrease the temperature. Good. So we're just talking about each one. Particle size. What was he talking about there in the video? The groups, the packs. Okay. Right. So if I'm making Kool-Aid with sugar cubes, it's going to take a while for everything to dissolve, right? But if I make it with powdered sugar, which has a lot more surface area, it dissolves almost instantaneously. So particle size is a big deal. Okay. We're going to be working with both temperature and particle size in the lab that we're going to be doing. So think about it. This cube has only the outsides exposed, but if I cut it and keep cutting it, I'm going to expose more and more sides. I'm going to have more surface area. All right, so the next one was concentration. What was he relating that to in the video?
Like making the population more bigger.
Right, making more people go to the school, right? So if I were in, I know I use this a lot, Lima, Montana, graduating class of 5, compared to here, which is graduating class of 800 and something, my chance of probably finding somebody that I get along with is probably greater here, right, than in Lima, Montana, especially if there's 4 guys and 1 girl, or 4 girls and 1 guy. Okay, so the chance of finding somebody is a lot harder. Same thing here. If I have the same amount of solvent, if I just put a little bit of solute in, that's like putting just the people from Lima into the mix and saying, okay, we need to make matches. Versus a lot of salt on the far side, the right, in the same school environment, and we got a lot more choices. So concentration, well, how does it affect? The more concentrated or the more particles, the faster the reaction is going to happen. The less particles, the slower, right? So dilute would be slow, concentrated would be faster. And then we talked about the catalyst or the matchmaker. Now we've seen this graph before. Does anybody remember what the name of this graph is? We've done this graph before. It started with an A. It's an activation graph, activation energy graph. Okay, so we have seen the one on the right before where the catalyst lowers the activation energy and makes it lower. The one on the right is actually more what catalysts do. They don't just lower it, but they change the mechanism. So on the right, it just shows the same up and down, up and down. On the left, it shows more of a pathway, the pathway's changed. And so what I think about when I'm looking at the one on the left is I could go up and over a mountain, or I could take a trail that goes around the mountain. And as I go around the mountain, I might have some little ups and downs as I'm going around the mountain. But I'm still going to get in the same place. Still start with the same place, end at the same place. Okay, so catalyst lowers the activation energy. Sometimes it speeds it up, like this one, it would speed it up on the right. On the left, it might not speed it up, but it lowers the activation energy. It lowers the amount of energy, so I don't take as much heat to make it through. Okay? So we're going to do a demonstration now. I'm going to run back and get some dry ice. Front row, we need to have you in goggles. So I'm going to pass some goggles around. Okay? And I'll be right back. I'm going to pause this video and I hope you enjoyed it. It was sort of fun. All right, so we're going to talk a little bit about graphs. And as we're looking at graphs, the slope on the graphs will tell us how fast a reaction is taking place. If the slope is more vertical, that means the reaction is taking place quickly. As the slope starts to flatten out, that tells me the reaction is going slower. Now, the one that we're seeing right now is a reaction of bromine. And this is a one-way reaction because notice we get to the 0. Okay? And so there's no going back. I now ran out of bromine and I can't go backwards. Okay? When we have a reaction that will go both ways, it will never get to 0. It will always be above 0. And so we end up with them crossing, products and reactants. As we're looking, like I said, the reaction is I've got a steep slope is the fastest. Then it starts to slow down, and then the reaction's over. So I sort of relate this. This is a funny way to relate it. But in Utah, you graduate from high school between 18 and 21. Most eligible people become married in Utah. Okay, if you get to be about 32, 33, you're considered old maid. And there might be 2 or 3 of you living in Utah, and you're so far apart it's hard to make the connection. Okay, anywhere outside of Utah, about 30, 32 is when they're getting married, and so you still have a lot of people to choose from. So the fastest reaction rate for getting married in Utah is between 18 and 21. And then it starts to slow to the point where now there's no reaction rate, and you become the old maid unless you move out of state, or the old bachelor. So as we're looking at it, we can actually find what's called an instantaneous rate. Now, if you go on to calculus or go on to stuff like that, you know you can find an instantaneous rate any place on a graph. And we use that. It's basically the slope. Okay, the slope is your rate because we're going moles on this side or molarity on this side versus time. So if we find the slope at any given point, we can say that's the rate at that point. That's an instantaneous rate. If you do integrals and stuff, you can find the overall. What I'd like you to do now is bring up Google and type in FET simulation, reactions and rates. FET simulation, reaction and rates. Just go ahead and type it in. What's in the pink there? It doesn't have to have the parentheses. Just type it in. So there's a few things that I would like you to do on this. I want you to add heat. When you get it up, you're going to have to say download, and then you're going to need to say open or run. I can't remember which it is, open or run. So you got to download it, and then I think it says open. Okay, I also want you to try what happens when things are added. Now I think I've got this up, but I don't remember where it is. It's right here. Okay, so this is what you should be seeing when it comes up. This will be closed, and this will be closed. I want you to just tap those open. Okay, so you can see the activation curve. You can see the distance apart from each other. You can choose what reaction you want to do. You can choose a bunch of different things. You can do lots of many collisions. You can change the pressure in by going up and down. You can do rate experiments. I want you to just play with this whole thing and see how things react. Okay, so if we go back to the single one, we can take and we can launch things. Maybe I want to redo it. I want to launch this one instead. So you just bring it down and you launch it. And you see what happens. Maybe I want to increase the temperature. Maybe I want to decrease the temperature. Okay, I want to see what's happening here. So this is what's going on. I can also go to many collisions where I'm now, let's see, we're going to add this one. I'm going to take and pump things in. Okay, so I've got a lot of things coming in here that are reactants. I want to heat up the temperature, see what happens. I want you to just play with it for a minute. Okay, I'm going to bring you back in about 7-8 minutes. So just play. Basically, what we're doing today, we basically finished all the lecture last time. So we are using today to get pre-labs ready. We're doing the juice enzyme, and we're doing the DNA, I believe it is. Is that the one, the yeast, or the DNA extraction. Okay, so we're going to do those, get those ready to roll, and then I'm going to try and squeeze in another lab right here, which is drug testing, and we're doing it on brine shrimp. So we're hoping to squeeze that in right here instead of with the cleanup here. So these 2 days would be the brine shrimp one. I'm just trying to find live brine shrimp. So that's the holdback. We've got everything else. So basically remember that test was available from March 12th to March 16th. We'll start a new unit coming up. Might even be on the 8th, to tell you the honest truth. The reason why I will be gone the 12th and the 14th of March to watch my grandkids. So I'm going to be trying to get ahead a little bit. So those 2 days you guys can have work days and sort of clean up and do pre-lab or whatever we need so when I come back. Also, here's the big one. Last night I got told that I get to have surgery on March 27th. So because of that, that is the Tuesday before spring break. So I'll be gone Tuesday, Wednesday, Thursday, Friday that week. Be gone spring break. Be gone the week that we come back from spring break. And then I'm hoping to be back. So I'm going to basically try and leave you with video notes, and you can email me and I'll try and email back if you need help. Mrs. Bagley is a good resource because we're now into biochem, which she knows real well. So that's what's going on. Okay, so heads up. Remember I told you that all the tests are going to be a little bit weird anyway as far as when they're due. So please watch your Canvas. I'll try and keep that up to date from at home. And I'll try and link your videos from there too. Okay? So, yeah. There you go, get my throat slit. They're going to fuse C 5 and 6. So the 27th through the April, the first week in April, second week in April. I guess. Yeah, the doctor says, oh, you'll be fine, you'll be up the next day. And I looked at him and go, you don't know me very well, do you at all?
No, I was like, going to get your tonsils out or go on a trip. I said, well, obviously, no. I'll do that another day.
So just FYI, that's coming up, and the 2 days, and they happen to be A days, the 12th and the 14th, and that's the last week of this term. and then I'll be back on the 16th. But I will be here on B days, so if you need help coming on B days, and I'll be here that week on B days. It just so happened the way my husband could take off work and the way I could cover the grandkids during the 10 days we have them, it was both B days that I had to take off, or A days, sorry, both A days. Okay. All right, so what we're going to do today is you've got both labs. You need to go through them. I don't think there is a pre-lab on either of them, but you need to get them set into your lab notebooks, ready to roll. You need to understand what you're doing because you need to have both labs ready to roll and due Wednesday next week. Okay, we will correct 11.2 at the end of the period. Start working on getting as much of those problems done as you can, 11.2, 11.3, 11.4, 11.5, whatever you can get done, because we're going to be lab heavy towards the end of this unit. And that'll help you get ready for the test too. Okay, any other questions? Okay, time's yours.